so these are some sample questions involving the gas laws, and I've quickly up here, what you can see is I've written down the three laws that we know. That's Boyles Law, which involves pressure and volume. As I increase the pressure, the volume decreases, or as I decrease the volume, also the pressure increases. Think about a syringe where you're pushing a syringe in. We have a decrease in volume, it gets smaller, and the pressure increases because we can feel that pressure build up as we push the syringe down. Charles's law, we have the effect of volume and temperature. Let's change this to a V here, which says as I increase the temperature here, I'll increase the volume. So if I heat something up, the volume will increase. That's at a constant pressure as well. So we have a volume over T for temperature equals volume over temperature. That's a ratio. Avogadro's law involved number of moles because Avogadro, as you know, loved the mole. He's said that volume over number of mole equals the volume over number of mole. So volume is proportional to the number of mole we have. Excuse me. So look at the first question. If a sample of gas is heated, of a fixed volume is heated, what's going to not happen here? So we have a sample of gas, okay? The volume's constant, so we're going to keep the same shape here. And all we're going to do is heat this sample of gas. So we'll put a little flame under here so we can see it's heating. Okay, heating means giving them energy. So if we give molecules energy, they're going to go faster. They're going to speed up. Okay, so this first one, the average speed of the molecule will happen, so it's not going to be that one. The pressure of the gas will increase. Now if we heat things up, they're moving faster. What you're going to get, and if we keep the same volume, is we're going to increase our pressure. So that's not going to happen. That is going to happen, I should say, as well. So it's not going to be that one. So increase in the temperature, it increases the pressure that we have as well. You can think about heating up a can, a closed can or something like that, and it's going to eventually pop. The density of the gas will increase. Now density is related to how many things are in this volume. So it's how many particles are there. Now what you're doing is you're heating up this gas. You're not adding any more to it. So this could well happen. You're not adding any more molecules in there, so the density will stay the same. Now have a look at this. The average frequency of collisions with the walls will increase. Now as you're heating something up, the molecules are moving faster, therefore they're more likely to hit the wall. If they're moving faster, you're going to hit the wall more often because you're moving faster. So this is wrong as well. So the answer has to be C. The density of the gas will increase. And that's my logic behind it. Okay, notice when we're talking about heating something, we're always talking about moving faster. The particles moving faster. Okay, so that's the theory behind this one here. Moving on to the second question, it involves a bit of a calculation here. Now, a flask of mass, 80 grams, is filled with carbon dioxide. It has a molar mass of 44. Its total volume is now this. Total mass, I should say. I've copied this out wrong. Its total mass is this. If carbon dioxide is replaced with carbon monoxide with this molar mass, under the same conditions, the total mass of the flask will be. Now let's have a look at this. Okay, we have our mass of our flask is 80. Our total mass is 82.2. So that means the mass of carbon dioxide equals 2.2 grams. Okay? The number of mole of carbon dioxide is going to be equal to the mass divided by the molar mass, which will be 2.2 divided by 44, which equals. That equals 0.05 mole. Okay, so now we have a number of mole. Now, we have the same conditions here. So if we have the same conditions, we need to look at our laws here, which relate volume, okay, and number of mole. And we see that volume and number of mole are proportional. So if we have the same conditions, what we must have is the same number of mole in our next flask. So the number of mole of carbon dioxide is this, and because we have the same conditions, the number of mole of CO will also be equal to 0.05. Okay, because that's related to Avogadro's law here. So because we have the same conditions, our number of mole of CO, our carbon monoxide, is the same as our carbon dioxide. Now, so we have a number of mole of carbon dioxide. What we can do is convert that into a mass, which equals number of mole times molar mass. So that means we have 0.05 times, it's 28. So that will be equal to 1.4 grams. So that's our mass of carbon monoxide is 1.4 grams. Now our flask here, it weighed 80 grams. So the total weight of the flask and our carbon monoxide must be B. And this is all related to Avogadro's law, saying that if we have the same conditions, that means the same volume, the same pressure, the same everything else, we'll have the same number of mole in those two flasks. That's regardless of how big or small the molecule actually is. It will be the same mole. It's a different weight, but it's the same number of mole. Okay, let's go on to the next one. Hang on.